All right, students, let's go ahead and get started. We're talking about, in Unit 5, the mole. First, let's start off and talk about what a molar mass is. A molar mass is the sum of the atomic masses of all atoms represented in a formula of any compound or polyatomic ion. That's a pretty intense definition there, but just to reiterate, a molar mass, basically, if you had a compound or an element, a molar mass is just adding up all of the masses on the periodic table of that compound or element. Now, we'll have an example pretty soon, so if you just stay in touch, hopefully you'll understand. Now, the molar mass of an element is literally just the average atomic mass found on the periodic table. So carbon's molar mass right here is 12.011. So this is found on the periodic table. The molar mass of carbon is 12.001. And we're going to use that to figure out the molar mass of a compound. So let's look at a compound such as CO2 or carbon dioxide. This covalent compound here, we want to be able to find the molar mass of this entire compound. So if you recall from previous, the molar mass of an element is just the mass on the periodic table. And previously we learned that the molar mass of anything is just all of the atoms added up. Let's go ahead and find the molar mass of carbon dioxide. So let's see, carbon dioxide is made of one atom of carbon. So if I go look on the periodic table at carbon, 12.01 grams per mole, that's the molar mass of just carbon. And because I have one atom of carbon in my compound, I'm going to go ahead and take that, times it by 1, and that gives me 12.01 grams per mole of carbon in that compound. Now, how about oxygen? There are 2 oxygen atoms in carbon dioxide. Now, if I go look on the periodic table, the molar mass of one oxygen is 16.00 grams per mole, but I have 2 atoms of oxygen, so I'm going to go ahead and multiply that number by 2. That's going to give me 32.00 grams per mole for oxygen. The last thing I need to do is just add those 2 numbers together, and I'm going to get the molar mass of my entire compound. So here's the molar mass of carbon dioxide. Now, why is this important? Well, this is going to be important for us to do calculations with carbon dioxide, such as this practice here. So you might be given a problem like this. What mass does carbon dioxide have if I have 4 moles of carbon dioxide? Well, I'm given 4 moles, so I have 4 moles of carbon dioxide. Now, I need to convert that from moles of carbon dioxide to grams of carbon dioxide, or how many grams does 4 moles of carbon dioxide equal? Well, this is where our molar mass comes into play. I'm going to go ahead and take my 4 moles of carbon dioxide, and I'm going to multiply it by the molar mass of carbon dioxide, what we just found out in the last slide, 44.01 grams per 1 mole. That's the molar mass of carbon dioxide, and that is a conversion factor. That's not necessarily anything directly related to my problem, but it is indirectly going to help me figure out a conversion between 4 moles of carbon dioxide to grams of carbon dioxide, because I know it takes 44 grams per every mole. So if I set it up like this, where I take 4 moles of CO2 and I times it by the molar mass over 1 mole, that is a conversion factor. I'm going to go ahead and take that 4, times it by 44.01 grams, and divide it by 1 mole. Because moles are on opposite side of this division line, the moles cancel out, and I'm left with grams. Specifically, I'm left with 176.04 grams. That's what I find in my calculator. But according to sig figs, I really only have 177 grams of CO2. So 4 moles of CO2, using my conversion factor, I figured out that I have 177 grams of CO2. So this brings me to the molar mass. The molar mass of a compound is equal to 1 mole. But also, this is going to help me further. It also is equal to 6.02 times 10 to the 23rd molecules or atoms of that compound. So this is an important number here, and we'll get to that number next. But the molar mass, the things found on the periodic table, is equal to, when you add them together, you get 1 mole, and that's a conversion factor. But that is also equal to a certain number of particles, 6.02 times 10 to the 23rd to be specific. So let's do this next practice. How many molecules are in 4 moles of CO2? Well, we just figured out how many grams 4 moles of CO2 is, but how many molecules is 4 moles of CO2? Well, we're going to start with 4 moles of CO2. Now, according to the last slide, we have another conversion factor, and that's 6.02 times 10 to the 23rd per mole. I know that if I have 1 mole, that's 6.02 or 602 sextillion particles or atoms. So if I use this conversion factor, by the way, this is called Avogadro's number. If I use Avogadro's number and I take 4.0 moles of carbon dioxide, multiply it by Avogadro's number per 1 mole, I'm going to get my answer. That's literally taking 4.0 moles of CO2, timesing it by 6.02 times 10 to the 23rd particles or molecules, and then dividing it by 1 mole. The moles canceled out. I'm left over with just the number of molecules, which is specifically 2.04 times 10 to the 24 molecules. So let's go back to kind of molar mass. I need to be able to find the molar mass of something before I convert between moles and grams of a substance. So let's try barium hydroxide. So try to do this one yourself. I challenge you to pause this video right now to try to figure it out. Did you pause the video? If so, great. Let's see if you figured it out by yourself. So I'm going to go ahead, start with 1 barium atom. So if I look at my compound formula up here, I have 1 barium atom. If I look on the periodic table, barium is 137.33 grams per mole. Because I have only one of them, I'm going to multiply it by 1, and that gives me 137.33 grams per mole. Now let's look at oxygen. If I FOIL this number in, by the way, this is hydroxide, and if I have 2 hydroxides, that means I have 2 oxygens and 2 hydrogens. So those kind of get FOILed into our problem right here. So I have 2 oxygen atoms. So I'm going to take my molar mass of oxygen from the periodic table, times it by 2, and that gives me 32 grams per mole. Finally, I have 2 hydrogen atoms also foiling it in. Each hydrogen atom has 1.01 grams per mole, so I multiply that by 2. That gives me 2.02 grams per mole, which if I add all of these 3 separate molar masses together, I get a total molar mass of my compound of 171.35. All right, so this leaves us to the last practice problem. See if you can figure this one out. What's the molar mass of calcium phosphate? Did you pause the video? All right, let's try it out. So I have 3 calcium atoms. If I multiply the calcium molar mass by 3, I get this, 120.24. I have 2 phosphorus atoms, so because I'm foiling this 2 into phosphate. By the way, this is calcium phosphate, so I'm foiling the 2 into phosphate. So I take 30.97 grams per mole, that's found on the periodic table, times it by 2, and I'll get this as a molar mass for the total number of phosphates. Oxygen, I have 8 oxygens. Again, foiling this in, I need to multiply my 4 by 2, so 16 is the molar mass of oxygen. I times that by 8 atoms in my compound, and I'm going to get 128. When I add those 3 together, I get a total molar mass of calcium phosphate to be 310.18. All right, so just as a kind of a comprehensive review, this is not found on your note packet, by the way, but it's a useful thing to write down. You're doing molar conversions, and what you need to do is you need to be able to convert between grams of something and moles of something. Now, to do that, again, I might write this diagram down. It'll be very useful to you. In order to go between grams of something and moles of something, you're using something called the molar mass, and that is calculated using the elements found on the periodic table, just as we did in the last 2 practices. Now, specifically, if I wanted to go between grams, if I wanted to go from grams of something to moles of something, then I'm going to times it by 1 mole over the molar mass in grams. When I do that, my grams will cancel out being on opposite sides of this dividing line, and I'll be left with moles. However, if I want to go from moles to grams of something, this time I'm going to multiply whatever moles I have. I'm going to multiply it by the molar mass in grams over 1 mole. So they're kind of opposites. So if I'm going from grams to moles, in essence, I'm kind of dividing by the molar mass. But if I'm going from moles to grams, I'm kind of timesing it by the molar mass, depending on where it's at here. So that's 1 molar conversion you need to know. You need to be able to go between grams and moles, and you're going to use the molar mass in order to do that, either timesing it by 1 over the molar mass or timesing it by the molar mass over 1 mole. The other thing you need to be able to do is go from moles to numbers of atoms or molecules of a substance, kind of like what we did in the practice previous. Now, to do that, we're going to use the special number 6.02 times 10 to the 23rd. It's called Avogadro's number, and that number is equal to 1 mole. So how do I do that? Well, if I had moles of a substance and I needed to get numbers of atoms or molecules, then I'm going to take my moles and I'm going to multiply it by 6.02 times 10 to the 23rd over 1 mole. By the way, this is mole, not molecule. So take my number of moles, times it by Avogadro's number, and I'll get numbers of atoms. But what if I had numbers of atoms and I needed to go down and back to 1 mole, or to moles? Then what I do is I times that by 1 over 6.02 times 10 to the 23rd. That's almost in essence taking the numbers of atoms and molecules in my problem and dividing it by 6.02, but I like to think of it this way because in every instance I'm multiplying by something. So to go between grams and moles, I use molar mass. To go between moles and atoms, I use Avogadro's number. Notice there's no way to go from numbers of atoms directly to grams. I have to go to moles first, and then I can go to grams. Same thing, there's no way to go directly from grams to numbers of atoms and molecules. What I need to do is go from grams first into moles, and then moles into numbers of atoms and molecules, using both the molar mass and Avogadro's number. Well, that's all I have for you for this video, guys, and go ahead and, if you need to, you're welcome to rewind the video, watch parts if you need them. You can pause the video. I encourage you to talk with each other to try to understand. I encourage you to go and talk with your instructor if there's something you're not understanding. But more importantly, try out some of the problems yourself. Use this molar conversions chart that you've written down. It will hopefully be very helpful for you to figure out the different parts. But good luck. See you next time.